So far we know how to compute the total number of subsets of any set. For example, for a set A, we know that the total number of subsets can be computed using the formula 2 to the power of n, where n is simply going to be the number of elements in the set we are asking the question about. So for example, if we want to know the total number of subsets in A, we would say this is going to equal to 2 to the power of 3. Where did we get this 3 from? Well, it comes from the fact that A has 3 elements. It has the number 3, the number 2, and the number 1. So that's where we got the 3. Plugging this into our formula, we get that A has a total of 8 subsets. Okay, well, what if we ask a more specific question? Specifically, how many subsets does A have in total that are size 2? What does this mean? Well, picture that all of the subsets in A are inside of this circle. I'm going to represent them all using dots. 1, 2, 3, 4, 5, 6, 7, 8. So all of the subsets of A are inside of this bubble. And we already know how to compute how many dots are going to be in this bubble using this formula. That's how I knew how many to draw. Well, to ask what size means, size is simply asking the number of elements. So in this case, a set has a size equal to the number of elements it has. So A, for example, here has size 3 because A has 3 elements, similarly to how we got the 3 here. Well, let's write out all of the subsets of A. So, we know what size means. Size means is when you're looking at a set, you're asking how many elements are in the set. We know that we're looking at the size of subsets. So here are all of the subsets. These subsets each correspond to a dot, right? There's 8 here and there's 8 dots here. So what we're asking is, how many subsets does A have, this is the total, that are size 2, which means have 2 elements? Well, if we look here, we notice this set has size 2, this subset has size 2, and this subset has size 2. So you can think of it like if you have a huge circle with all of the subsets of a set, what this question is asking is, if we carve out this little area, how many subsets are going to be in it? And this area, for example, in this case would represent size 2. So we're asking how many subsets are going to be in this little area, and this area represents size 2. Well, we know the answer in this case is in fact going to be 3, because we can write them all out and we can visually see, well, there's only 3 subsets of A that have size 2 or have 2 elements. But how would you do this for a more complicated problem? To do that, we're going to have to introduce some new notation. The notation I'm going to introduce is going to be the choose notation, where it's going to be in the form of n choose k. That's how you read this, n choose k. And what does this mean? Well, this means that the top number is going to represent for us the total number of elements in the set in question. So for example, in this case, the total number of elements in our set in question, the set in question is going to be A, is going to be 3. So our n is going to be 3. Then k is going to be our choose element. So n choose k means we have 3 elements in our total set here, and we're asking ourselves, well, they have to be size 2, so we want 2 elements, right? We're going from 3 elements, and we want to choose subsets that have 2 elements. So we start with 3 elements, and we want to choose all of the subsets that have 2 elements in them. This notation oftentimes is equivalent to the formula n factorial over k factorial times n minus k all factorial. So in this case, for our question here, it would be equal to saying 3 factorial, since this is the set notation we're going to now use for these types of questions. We have 3 elements in our set, and we want to ask how many subsets have 2 elements. This is going to be the same as computing 3 factorial over 2 factorial multiplied by 3 minus 2 all factorial. Well, we can just write this out. 3 factorial is 3 times 2 times 1 over 2 factorial is 2 times 1. 3 minus 2 is 1. 1 factorial is just 1. What do we notice? Well, we notice the 1 up here cancels with the 1 down here. The 2 up here cancels with the 2 down here. So we end up getting 3 over 1, which is going to be 3, which is exactly the answer we got when we wrote out all of the subsets of A and looked to see how many of them have size 2, how many of them have 2 elements, which is 1, 2, 3, exactly what we got down here. This is going to be the new notation, the second piece of notation we're going to apply to our counting problems.